In our last Unit 7 quiz preparation video, we accomplished these questions. Now let's look to see if we can get you some help on some additional questions. These that you're going to potentially see questions of this similar to this on your Week 7 quiz. So let's take a look at this one first. Evaluate 3 log base 7 of 10 minus log base 7 of 5. Okay, well, again, you'll notice these two logs have the same base, and we have subtraction, which we know can be turned into division by our property of logarithms. So we're going to go ahead and do that. So we're going to have one big log base 7, and we're going to have a division problem. And there's the numerator and denominator are separated by the subtraction symbol. So the numerators, we're going to take this 3 and we're going to make it an exponent of the 10 cubed, and that's, again, a function of our properties of logarithms. And then this one is just going to be the 5 in the denominator. Okay, so we're going to have log base 7 of 10 cubed, which is 1,000, over 5, which is log base 7 of 200. Okay, that's the answer to that. And what I think the question might be like on the quiz isn't just this looking for a solution, but it's saying which of the following evaluate to this. And so you have to kind of check out all of the different options to make sure they all evaluate to this value. But this is the solution. The solution is log base 7 of 200, which if you wanted to get an actual number for it, you could, but we'd need to use the change of base formula because there's no log base 7 button on your calculator. So to convert this to a different log base, like log base 10, we say log of 200, which is this guy, divided by the log of 7, okay? And again, this is log base 10. We don't write the 10, but that's what it will look like on your calculator, just the log button. And when you plug that into a calculator, you will get an actual number, okay? So that's how you do that one. Let's take a look at the next one. The next one here, solve for x 3 e to the x plus 5 equals 14. Well, this is an exponential function with a base of e, which is a constant. Okay, and so we just isolate this to start with. Let's isolate this term. So we're going to subtract 5 from both sides. And we're going to be left with 3e to the x equals 9. Divide each side by 3 to continue to isolate. We have e to the x equals 3. Now, if we have e to the x, the way to undo an exponential function by applying its log function. So if we apply the ln of e to the x, that's just going to return back x. Remember, when we compose inverse functions with each other, we get back x, right? And ln and e are functional inverses, right? So if we take each side to the natural log, then this left side is going to be left with just this x in the exponent. And again, that's because we're composing f of x with f inverse of x, something we learned back in Unit 2. When we do a composition of a function and its inverse, we're left with just x. And so we have this wonderful trick we can play where we just take the natural log of both sides, and it allows this x to come down by itself. So then we have x equals ln 3. You can plug this into your calculator to get an actual number, if that makes sense. But that's how you solve that one. Okay. Now let's look at this one. Solve for x 3 to the x minus 1 equals 27. Well, we've seen these before. 27 can be expressed as a power of 3. So 3 to the x minus 1 equals 3 cubed. Now that we have the same base, we can simply set the exponents equal to each other and solve quite simply x equals 4. That one was quite simple. How about this one? Domain and range of log base 2 of x. Well, let's not forget, we have to memorize. We really have to learn the parent graph of the log function, of log of x. And it goes, it's the mirror image of the exponential graph, and it has a vertical asymptote as the y-axis, and it climbs like this and then takes a hard right turn and grows very slowly, going off into positive infinity. So the question is, so this is kind of what the log base 2 of x is going to look like. It's going to look like that, and it wants us to know the domain and range. Well, the domain is all possible x values. Well, you notice we have no x values at 0 or to the left of 0. We don't have anything that direction. All we have is x values that are in the positive side of the y-axis, the positive side of the y-axis. So all of our x values are out here going off to infinity. So our domain is values of x that are greater than 0, right? Because it never touches 0. It's not greater than or equal to, because this line never, this asymptote will never touch the y-axis and where x is 0. Okay, so the domain is x is greater than 0. And the range, of course, well, you can see that now we're looking at the y values up and down. We're looking up and down instead of left and right. And you can see that it's certainly going to hit every value going to negative infinity just by virtue of the fact this thing's going to continue to go down the page. It's also, believe it or not, as slowly as it's going to grow, it is growing. And over time, it's going to eventually keep climbing up and up and up and up, so that it's going to eventually hit every y value above the x-axis. So this is going to be negative infinity to positive infinity is the range. Okay? So that's how we determine the domain and range of that logarithmic function. And last but not least, we got one more domain and range question, and it's the exponential function, not the logarithmic function. And what you're going to see is the domain and range is going to be literally the opposite, because these are inverse functions. So let me first draw it. At the point 0, 1, we have a horizontal asymptote, and 2 to the x climbs very fast. This is y equals 2 to the x, okay? And so we want to find the domain and range. Well, in this case, the domain, which is the set of all x values, we're looking left and right now, looking left and right. You can see it's going to hit every single value going left all the way to negative infinity. And you can see that it's probably going to hit every x value going out to the right, even though it's going to do so slower because it's climbing so fast, but it is still moving right and will eventually hit every x value to the right. So the domain is all real numbers, or as we said in the last question, it's going to be negative infinity to positive infinity. Okay, that's the domain. The range, which is all y values, the range is all y values, is all we have to do is focus and look at up and down. Let's look up and down. Where do we see the graph not happening? Well, clearly there's nothing going on down here in the negative y range, right? So we only have y values that stem from not quite the origin all the way to positive infinity. So we have our x is going, or excuse me, our y is going to have to be greater than 0, right? Notice our y is going to be greater than 0. It's not going to be greater than or equal to 0 because this asymptote right here never touches 0. It never touches the x-axis. It goes on and on and on, comes ever so close to it, but never touches it. So our range is going to be y is greater than or equal to 0. I hope you found the videos on your prep for the quiz helpful. I think they're probably going to give you a leg up when you take the quiz this week. Good luck.